Hello and welcome. My name is Morey Haber. I'm the Chief Technology Officer and Chief Information Security Officer here at BeyondTrust. For today's session, we want to discuss the path to Zero Trust with least privilege and secure remote access. For our agenda, we're going to discuss what is Zero Trust and what it means to you on how to properly architect solutions and risk mitigation. Then we're going to discuss privileged access management and Zero Trust architectures. Finally, we're going to wrap up with remote access and Zero Trust. To begin, for those of you that are not familiar with what Zero Trust is, it is a foundation set of principles used to design security architectures with the core concept that nothing in a network environment should be trusted until it has been verified. In other words, Zero Trust implies that the traditional security controls of a perimeter, access control list, firewalls, etc. need to be discarded or not used as the primary method of trust for a session, an application, or network access to be conducted. We're going to use advanced techniques in order to achieve a trusted session. This also implies that local accounts and other things that are used primarily for the start of a session or the authentication of a session may not even be present. Secondly, traditional security controls and policies focused on securing the perimeter don't always translate to the new realities of digitally transformed environments. This implies that hybrid environments, cloud environments, and remote workers can't use traditional security controls alone to establish trust. We must find a better way, newer techniques, and rely on behavioral attributes and characteristics of the session, the user, and their behavior to determine if a session is operating correctly. Now, you'll find that many vendors define Zero Trust in a variety of ways, from the network layer all the way up to the application. But for the sake of this session, we're going to rely on NIST 800-207 to define Zero Trust. The main goal of Zero Trust, according to NIST, is to prevent unauthorized access to data and services, coupled with the making of access control enforcement as granular as possible. In other words, we're not using the network anymore to control or gate access. We're going to use access control information with granular details from traits, attributes, and behaviors to determine if a session, application, or even a connection should be trusted. Now, the Zero Trust term itself is an evolving set of cybersecurity paradigms that move defenses from static network-based perimeter controls to focus on higher levels of the user, asset, and resources. We're no longer thinking of security as blocking an IP address, establishing just a firewall rule between one IP address and another. We're using other context and information to establish that, yes, that session should occur, and maybe even that user not even have an account on that remote system in order for them to be authenticated. Now, NIST guidelines provide a clear playbook for organizations looking for guidance on how to adopt Zero Trust principles. And I'd encourage anyone listening to this presentation that's not familiar with Zero Trust or even the NIST paper to go ahead and look at it. It will really help clarify the problem. Now, we're seeing a paradigm shift. That traditional moat and castle approach to our data centers, our information, and our applications. Traditional data centers can be thought of as a castle. We had our crown jewels in a data center with a moat surrounding them and all sorts of network controls, zoning, VLANs, etc. to protect that information and only allow certain workflows to cross network boundaries. With Zero Trust, we're going perimeterless. That means even though we may still have network zones, the controls at the network layer are not the only thing we're using. In fact, we're continuously adapting those controls based on the user, the device, the location, the application, etc. The model here is never trust anything. Verify the connectivity, verify the appropriateness of the connectivity, and establish a baseline or set of policies and rules that continuously adapt to what is appropriate for user behavior. Now, this may seem really hard to do, but in essence, it's not. Now, a product is not zero trust. A product cannot be zero trust. However, an architecture, a solution, and a way that it is implemented can help you with this paradigm shift from a traditional moat and castle to perimeterless, such as concepts of least privilege, just in time, and a variety of others, including machine learning and AI, can help you achieve a zero trust architecture. Because a zero trust view of the network is not the same thing as what we've seen before. The entire enterprise is not a private network anymore. It's not necessarily just one blob. It can be accessed from a variety of locations, especially again with remote workers, and we have to consider how we're going to let someone come into those network zones as appropriate. Now, devices on the network itself may not be owned or even configured by the enterprise themselves. We see this many times with vendors and contractors depositing appliances or other devices to monitor the services that they're providing to us, like an HVAC system or even a fish tank. Some of you may be familiar with that analogy. Therefore, no resource is inherently trusted just because it's on the network. Doesn't matter who it came from or where it was placed. And remote access to those objects or those resources or those assets cannot be fully trusted just because they've authenticated using traditional VPN technology or even some other form of remote access technology. You can't trust that the connection itself is good enough. You have to trust that the full session, the location, all of the attributes that we've discussed to that resource, including what is being done, is appropriate. And assets and workflows moving between the enterprise and non-enterprise infrastructure should be constantly monitored, maintained, and their policies reviewed, many times with automation, to ensure that nothing is being abused as a part of the process. Now, the shift to zero trust is significant. Under the assumption that every user, request, and server is untrusted until proven otherwise, a zero trust approach dynamically and continually assesses the trust every time a user or device requests access to the resource. This means static credentials, an always-on account or a persistent account is not the security model that you want to use. You are verifying each time that the user or the session or the application should be trusted and dynamically evaluating to make sure that everything that is being conducted is appropriate. Now, this is especially true if the session has been started and the person is trusted based on zero trust, but underneath the hood, there might be malware or some other type of attack that is doing something malicious. You want to be able to evaluate all the connections, all the services, all the applications, all the data control to make sure that the entire session itself is operating as expected. Now, this approach prevents attackers from exploiting weaknesses in the perimeter. And again, it also can help with lateral movement. Because if you know the user is supposed to be doing something like working on application X and a piece of malware or they're an insider threat or something is going awry, then you can detect, wow, I'm seeing inappropriate traffic on a port to another system or something else nefarious occurring. Now, the path to zero trust can be a little difficult. But once you understand the concepts, you'll realize that many applications can be architected to achieve it. And you might even be doing much of it today and not even realizing it. It's not a new concept, but it's a concept that has fundamental roots in a better way to mitigate risk. So many organizations have embraced zero trust frameworks and are building it into their security strategies as a way to stop a variety of modern threats, including attacks from the outside, malicious insiders that have been previously compromised, or even adapting to remote access or remote worker challenges. Now, the biggest challenge, however, is that the vast majority of organizations need to maintain legacy solutions either on-premise or that have been shifted or migrated to the cloud. Many of those solutions had their security controls based in network type perimeter-based controls, ACL lists, dependencies on network zones, hard-coded IP addresses for access, etc. Those don't necessarily conform to zero trust principles. And what you need to do there is build a zero trust model around it. The NIST 800-207 document thinks of things in terms of enclaves, where you can take legacy technology and put them in bubbles or even hardened zones to enable the remaining perimeter to be zero trust enabled. It's not perfect, but it'll allow you to adapt. But keep in mind, there are some legacy technologies that just can't do zero trust. Now, to build out a modern architecture that aligns with zero trust, you have to take a very pragmatic approach. You can't do it all at once, and you have to consider where your highest risks are and where you need to make the changes. Hybrid implementations are the biggest challenge in this environment to go towards zero trust. New initiatives embracing zero trust are actually the easiest ones to do first. And any new projects that your organization is basically starting with, like a new remote access system or starting with privileged access management, are your best bets to enable zero trust. And as we get more information about our environments, we'll be able to intelligently make those decisions in real time as they occur. Now, if you consider the modern attack chain, and this is a modified version of the Lockheed Martin attack chain, we have a variety of insider threats and external threats. Insiders can be intentional, or they could be compromised and not know it, essentially being mules for the attack, or external threats, attacking our cloud, attacking end users via phishing, etc. Their primary goal is to get some form of privileges, because privileges allow them to move around laterally. In addition, they also allow them to potentially access sensitive data, applications, resources, updaters, etc. The two primary methods that a threat actor would get privileges is through a vulnerability exploit combination. This is why vulnerability management and patch are still so critically important, and a privileged attack vector. That can be anything from spray attacks to brute force to reuse passwords to password guessing, etc. But once they compromise a system, the goal is to move around the environment to find additional opportunities to either plant more malware, do advanced reconnaissance, and potentially, exfiltrate data or some other form of denial of service. When we consider zero trust as a part of this model, we want to stop privileged escalation as a part of policy, especially in terms of excessive privileges that have been assigned, detect lateral movement, and ensure that the proper behavior of anything that occurs within the environment is monitored and managed appropriately. So instead of placing tools to say, I'm going to block one machine from talking to another, which might be appropriate, we want to make sure that the behavior and the techniques and the authentication used to talk to another machine all fall within the zero trust parameters, such that we know if something should be happening versus not. To give you a very simple example, Windows 10 by default allows to share updates between machines. It's a default behavior an administrator has to turn off if that's not what you want within your environment. So instead of downloading 10,000 copies of an update, it may download a few times, and then Windows 10 machines can share it with each other. That is appropriate lateral movement. That is expected behavior. What we're looking for things that is inappropriate, specifically in the middle. Behaviors, users, application, things that should not be operating that way. And that's what the zero trust model is designed to protect against. Now, when we consider all of this, we also have to consider the Achilles heel, the privileges themselves. If a threat actor gets privileges, it's game over, especially if those privileges are shared across multiple resources. And this is where privileged access management and zero trust comes into play. The role of privileged access management is to take those most sensitive accounts that you're going to authenticate in a zero trust model and place additional controls around them to ensure that not only the behavior is appropriate, but that it can be audited in great detail later with session recording, session monitoring, and other types of forensics. PAM solutions are designed to minimize privilege risk and enable zero trust by providing the granularity of privileges to decide exactly what's appropriate for every session. Basically, it is the enforcement point for least privilege, and if someone needs admin or root, it's done correctly. Now, depending on the goals, a variety of PAM capabilities are available through zero trust, and specifically zero trust architectures, so that the applications themselves are architected in a way where the perimeter controls are no longer required. You're evaluating things in real time from the command they type, from the program they execute, including elevation as admin or root. And ZeroTrust and PAM enable specific disciplines like just-in-time. If you remember in the beginning of the presentation, I indicated that you may not even have an account present as an admin, root, or other privileged user to perform a task. Just-in-time can be enabled through ZeroTrust and privileged access management, so an application, a task, or something can be elevated without even the user knowing what the local admin or a domain admin or some other type of sudo-based account is present in order to perform that function. The goal here is to reduce standing privileges. We want to get rid of all of those secondary admin accounts, all of those always-on accounts, and any account, even if it's managed under a password technology, from being present. Because even though you have the passwords in a vault, the account is still waiting for a connection. We want to get rid of all of that and reduce standing privileges so that we can dynamically provide time-limited access to privileged accounts in an ephemeral state just in time. And we want to be able to do this through a variety of techniques, whether the account is dynamically created just for that function, whether the account uses ephemeral tokens, whether it is provisioned through the SaaS control planes on demand, whether it is tokenization where the security token itself is swapped, or even whether the account itself is checked out from the safe, auto-injected, the application is elevated, terminated, and then the credentials themselves rotated or even disabled. We want to get rid of privileged standing accounts in every place possible so that in a zero-trust architecture, those special admin and high privileged accounts never become a risk for lateral movement or inappropriate behavior. Now, when we discuss this as a part of remote access in ZeroTrust, we want to think about a foundational approach for enforcing the philosophy of least privilege for remote access sessions. And we want to treat managed devices with the same level of trust as an unmanaged device. Nothing. That means that we don't know anything about the source. We don't necessarily care how it's patched or it has vulnerabilities. It's untrusted, but it may have a connection to a highly trusted source. This allows users to access what they need, when they need, how they need, even from their own home devices with minimal risk to the business. In addition, with remote workers and due to the current pandemic, many people are using home devices to do this type of work, and we don't necessarily know what their network environment is like. The foundations of ZeroTrust provide a clean path for remote access, no matter the health of the remote target, to a sensitive resource. But we can control. We can monitor and manage that behavior to make sure nothing inappropriately is occurring and that the path doesn't include some nefarious lateral movement. We want to do this for not only employees and contractors, but even third-party vendors that might be working in the cloud, hybrid environments, or even on-premise to get to the data and applications they need. Because realistically, we're using a lot more contractors and vendors to support our environment, again, in the cloud or on-premise than we ever had before. They can't necessarily come to our office. How do we securely give them access, not knowing the systems that they're using? ZeroTrust and remote access technologies can help us. And we want to keep those privileged users, regardless of the device, away from those traditional network security controls. Let's monitor and manage it better with a tool set that supports a ZeroTrust architecture. Now, ZeroTrust is about knowing who's doing what within your network and how they should be doing it. We want to limit the controls to the network. We want to find better ways of securing the access, but it starts to make sure that the behavior of the user is appropriate. Privileged access management solutions can be implemented with a ZeroTrust architecture to achieve this goal, as well as remote access solutions. So don't think of the tool as ZeroTrust. Think about the deployment as a ZeroTrust architecture to achieve all the goals that we've discussed and do it while solving the challenges of BYOD, privileged accounts, etc. When you wrap all of this together, you're going to take a universal privilege management approach to a practical and an intelligent implementation for the elements of ZeroTrust. and a security model that will not disrupt business processes and actually make them faster to implement. With that, I want to thank you. My name is Morey Haber with BeyondTrust. We offer a full suite of privileged access management solutions and remote access technologies with reference architectures for Zero Trust that can help you along your journey. Thank you and have a great day.